So something I kind of want to try is, what do you need to do on a Friday? Well, as of tomorrow, this is your checklist. 4.1 Delta Math, 4.2 Delta Math. If you've already done them, obviously you don't have to worry about it, okay? Then you had a worksheet, and it was titled Find Slope of the Line, right? Yes? Okay. All right. So today, in just a little bit, I have to set it to be live, but I am going to give you a Delta Math for today. But then you picked up a worksheet, right? So the worksheet that you picked up today, this right here is your Thursday/Friday work. Does that make sense? Like, however much you get done today, great, but those of you that are not going to be here tomorrow, that's what you should be taking care of. Those of you that are here tomorrow to take care of things, you know, you still have to do this, okay? You still have to do this. Just because you're here on Friday doesn't exempt you from this work, okay? Is everybody very clear on tomorrow's plan? Okay, just wanted to make sure. I'm trying to be helpful. Did you write this down? Did everybody write this down? I'm not sure everybody did. Okay, so let's go ahead and let's see how fast I can go through these notes so that I can give you some work time today. All right, I need one person from every tabletop. Please go over to the bookcase and get a ruler, like a regular wooden ruler for everyone at your table. I'm just going to use this because it's what I have handy. Okay, you are going to get, there we go, a ruler. Okay, so here we go. Ordered pairs. Now, if you are given a bunch of ordered pairs, you can put them in a table. Tables can be given to you like this, and tables can be given to you like this. And you need to be quite mindful. All right, back to what I was saying. Tables. Tables have a bunch of ordered pairs. These are going to create a line. They can be a vertical table like this. X is usually on the left. They can be a horizontal table like this. X is usually on the top row, but sometimes it is on the bottom row. So you need to be really, really mindful about which column is your X value, okay, and which column is your Y value. All right. Now, the other day, we graphed. So I'm going to show you how to graph. I'm sure you know how, but I'm going to show you what I expect when you graph. Okay? Because I'll be honest, I'm picky if you haven't figured that out. We need to graph them correctly. We're not making waves. We're not sketching feathery things. We're wanting a very precise, exact line. So I'm going to take all of these and I'm going to graph them right here. -5, 1, 2, 3, 4, 5, and then -8 is going to be all the way down here. Just a little note. This is a 10 by 10 graph. If this bottom line down here is -10, then 2 above it is -8. I don't have to sit here and physically touch every single corner. I can just know the layout of the graph. And then we have a -2, -3. Then we're going to have a 1, 2. We're going to have a 4, 7. 7 will leave 3 lines at the top. When I say lines, I mean the horizontal ones, not the boxes. Okay. And then 7 is 3 from the end and 12 up. Oh my goodness, what are we going to do? 1, 2, we're going to kind of eyeball it, right? We have to go off the graph. That happens sometimes. You could eyeball it. And then you're going to take your straight edge. Let me show you what I do not want to see. Everybody look, I don't want to see this. I don't want to see you go like that. Do you see how I just went from one end to the other end and I stopped? I want you to go past. So you need to go past that one and past that one. Doesn't have to be too far past it, but I want you to put arrows on the end because it's a line and it's going to and from infinity. Okay? And don't make lines like this. You see lines like that? Don't do that either. Okay? They need to be very precise. That's why we have a ruler. How was that? Everybody's done that probably at least once, right? Okay, so this other one here, now I'm going to show you something else. In this one, I don't recommend this because a lot of times people will do things incorrectly and they don't catch it. It's really best to graph all of them. Okay? But here, I'm going to graph the first one and the last one and the one in the middle. In theory, should it go through these points without me having to graph them? Yeah. So, for those of you that are like, I don't want to graph every dot. Okay, here's -8. And +9 is 1 from the top. There's that one. Then I'm going to have 0, +3. And then I'm going to have 8, -3. Okay, another note, if you do this, it's best that you graph in pencil because if you mess up, you have to erase it. So I don't recommend graphing in pen. So I'm going to line up the first and the last dots. Okay, so the minimum number of dots that I will accept from you will be the first one, the last one, and one in the middle. Okay, that's the minimum. How many is that? You have to have 3. I prefer 5, but if I can get 3 out of you, I'll take it. And then you have to verify. I want you to look. 1, 2, 3, 4. Is that a +6? Yeah. Over here, 4, 0. Does it go through the line? Yeah. So I verified it. I didn't graph them, but I did verify them. So if you do that, you need to verify. Okay, you don't always have a graph. Oh, we need to come up with the slope before we move on. So what we're going to do is we're going to look at our line and what's my rise and my run? Okay, rise over run. Okay, so it's 5 boxes up and 3 boxes over. Can you reduce that? No. Very good. Okay, I want to show you something over here. Do you ever want to verify it? What's the difference between -8 and -3? What is the difference between 7 and 12? 5. What's the difference between 2 and 7? 5. What's the difference between -3 and 2? 5. Do you see how all of these are my change in y? Isn't that what this is over here? Change in y? Oh, it should match your graph. Okay, and then this one, the difference here is 3, the difference here is 3, difference here is 3, the difference here is 3. When I say difference, I mean subtract. 7 take away 4 is 3. 4 take away 1 is 3. So this is my change in x. Does it match what I have over here? It does. It should all match. The table, the graph, the rise over the run, the change in your x and y's, everything should match. Okay, the slope for the next one, what do you think? You know that dot that we did not graph? That will be the smallest part of the ratio. But let's say that you went from that dot to this dot. Okay? How many is that? Rise over run. How many is this? 1, 2, 3, 4, 5, 6. Is it positive or negative? It's negative. Do not leave that negative sign off. Okay, and then how many is this? 1, 2, 3, 4, 5, 6, 7, 8. All right, can I leave my slope like that? What do I have to do? By. So I get negative 3 over 4. So this is my slope. By the way, I want you to look right here. If I go down 3 and over 4, do I hit that dot that I did not graph? Yep. And then just one more time, let's verify. What's the difference here? 3, 3, 3, 3. What's the difference here? 4, 4, 4, 4, 4. Now, my line is going downhill. Okay? And if you're not sure, well, if it's sideways, how do I know if it's going up or down? If I turn it like this, what are my y values doing? What are they doing? They're decreasing, right? The y values are decreasing. So that means my slope is going to go downhill. My y values right up here, these y values are increasing. That's how you know if your line is positive or negative without even graphing it. All right, now that we've done graphing, I'm going to zoom out and we're going to do a couple of these. Okay. Right here in this table, is y increasing or decreasing? This is increasing. The y's are going up, so my line would go uphill if I were to graph it. What's happening here? They're decreasing. What would my line do if I graphed it? It would go downhill. So that means I need a negative slope. This would be a positive slope. Okay? So, all right, we're going to do our slope. We're going to do change in y over change in x because it's all the same. What's the difference between 5 and 11? 6. 11 and 17. 17 and 23. 23 and 29. Okay, so the change in y is a 6. What about my x's? 2, 2, 2, 2. Right? And there's times where your table, we give you a table that doesn't work. It's not linear. It's not a line. So if you don't check that it's consistent for every single one, you might run into the fact that it's just a table of random dots and not a line. So you got to be careful. So this is a 2. So what's my slope? Okay, it's 3 over 1 or what? 3. There's my slope. Oh, hey, look, it's positive. It's because my y's were increasing. Okay, over here, slope is change in y over change in x. All right, right here. How are we going down? 10 to 3. 3 to negative 4. Negative 4 to negative 11. And negative 11 to negative 18. All right, that's consistent. So that's great. What's happening here? Okay. 3 and 3. That's also 3. That's also 3. Okay. So what's my slope for this one? Yeah, that's the slope. And it is negative. Okay. We're going to take a look at the next one. Oh. What do you guys think about that? Look back a page. Y equals Y, so what? Look back a page. What does it say in your notes? Right here, I'm showing you how to use your notes. If Y is equal to Y, then your slope is what? 0. Do you see this? That's your work. Everybody look at my screen right now. This is your evidence that I know that you thought about it. So, M is equal to 0. I would like you to give me all of that so that I know that you actually thought about it. Okay? If you're not going to do that, then you can do the change in Y over change in X like we did up here. Right here, X is equal to X, so what do you know? All right, by the way, I just want to remind you why that's happening. So I'm just going to do my change in Y every single time. There is no change, it's a 0. My change in X, we're going up by 2's. 0 divided by any number in the universe is 0. This is the math behind that. If I do it over here, the change in Y over change in X, what are my Y's doing? They're going up by 1 every time. What are my X's doing? They're staying, so that's 0. Any number in the universe divided by 0 is undefined. So that is the math behind that. Okay? How do you guys feel about all that? Okay. So you got to be able to get slope from a table and a graph. Let's skip over to page 9 and we're going to go to the bottom. Story problems. This is your favorite because you actually have to read sometimes 2 or 3 times. So let's make ourselves a note to read carefully. And I definitely mean read carefully. Okay, a slope in story problems always has 2 units, like miles per gallon, okay, days per month, dollars per ounce, right? Your slope is going to be your Y, let's say Y units, and over your X units. Okay, do you see these words right here? Yes? Okay. Y per X. Y for X. Y of X. So you're looking for those words. This for that. This per that. Okay, I'm using X and Y instead of nouns. And then X is usually time. Usually time. Okay. So, right here, we're going to drive 240 miles for, in 6 hours. Right? This is my Y, and that's my X. Oh, X is time. So, ready? Here's your slope. We're going to be talking about miles per hour. So I'm going to write 240 over a 6. Anybody know what that reduces to? We want to get this down to unit rate. What's the unit rate? That's from 6th grade. 40 over 1. So 40 miles in 1 hour. Everybody see that? This is your unit rate. It's your slope. That's going to help you graph. You always have, when you have to make the graph yourself, please label what your axes are and provide a scale. Okay, at 0, 0, I haven't gone anywhere, I'm still in the driveway. Okay, 1 hour, this is 1. 1 hour later, I'm 40 miles out. 2 hours, I'm at 80 miles. 3, 120. Okay, 4, 160. 5, 200. And 6, 240. You guys see that? Let me ask you this. Can you have part of an hour?
Yeah.
Can you have part of a mile? So because you can have parts, we're going to draw a line. You can have parts. Okay? This is your ultimate job, what I just did. Okay? Flip your page. I'm going to do these 4 examples with you, and then we're going to get started. Okay? On the practice work. Gabby pays $2.50 for 10 ounces. Do you see that 4 right there?
Yep.
Okay, so that's your y, that's your x. So your slope, okay, your slope, M, that's going to be dollars per ounces. So I'm going to put in here $2.50 over 10. Now I need to divide that. Ms. Bailey, you said slope can't be a decimal. You're right. But this is a story problem, and I can graph certain increments of money and time. Okay, so what is 250 divided by 10? Okay, it's 25 hundredths. In other words, it's a quarter, like in your pocket. Okay, slope is 0.25. What is that as a fraction? 1 over 4. Okay? Your label. Okay, so the other thing in a word problem, once you give me the slope, you have to give me a label. So this is 25, and we're going to say 25 cents per ounce. Okay? This right here means per. 25 cents for every 1 ounce. Now we're going to go graph it. I want you to look right here. My ounces are going by ones. That's easy. 1 ounce, 2 ounce, 3 ounce. Look right here on my money though. On my money, I have $0 and then I have $1. What do you think these little increments are here? Okay, those are 25 cents each. So, if you buy no strawberries, you spend no money. What if you buy 1 ounce of strawberries? 25 cents. What about 2 ounces? 50 cents. 3, 4, $1. Does that make sense? 4 times a quarter is $1. If I gave you 4 quarters, do you have $1?
Yep.
Yes. Okay. And then could we keep going? Right? Every time I add an ounce, I'm adding 25 cents to the amount of money that I would have to pay, right? And I can have partial ounces and I can have partial money. So I can use a line. Okay. Beth pays $1.50 for 12 ounces of honey. Do we need to do another one of ounces? Or are you good with that? Huh? Yes? What do you think? How many of you want me to do the honey? Okay. This is Y, this is X. M equals money per ounce. So $1.50 for every 12 ounces. I give them $1.50 at the cash register. I can take 12 ounces of honey home. So what is my unit rate for 1 ounce? $1.50 divided by 12 is how much? Okay, 125 thousandths. Basically, it's 12.5 cents. We don't pay with half cents, right? We have a whole penny or don't have a penny. Okay? But it's basically 12.5 cents. All right. So in this one, these are still going by 25s. I want you to see this. These are still 25s. How can I turn this into a whole, like an increment of 25? What would I do? 0.125. What if you multiply that by 2? What do you get? You get 0.25. Oh! So if I graph by 2s, 2 ounces, 4 ounces, 6 ounces, then I can use my quarters. No one wants to use a little half, right? So here's 1, here's 2, and here's 4, 6, here's 8. So I'm going to graph by 2s. 1 ounce would be right here. Do you see why I don't want to graph that? Look at it. I don't want to graph that. That's not very friendly. But 2 ounces is a quarter. 4 ounces is 50 cents. 6 ounces is 75 cents. Okay. 8 ounces is what? Huh? Is $1. Do you see what I'm doing? Does everybody understand why I'm going by 2s? I'm going by 2s because the 0.125, that's not very friendly to graph. So I just made it bigger. Okay, then I draw my line. So my slope was 0.125, you could say per ounce. You actually, if you say per ounce, you really don't even need this over here. But this is your answer. Do I have to label it? Yes. Yes, you do. Do you have to graph it? I don't know. If they give you a graph, graph it. If there's no graph, read the directions. Okay? Let's do these last two. Now, we have a total cost for weight, but what are we doing? We're mailing a package. In fact, I just mailed a bunch of packages the other day. So I actually had to do this so that I could buy my postage. These are already on the graph. I don't have to do anything. I don't have to graph it, but I do have to figure it out. So, you see how these are going by ones? right? Yes? Okay. And then, do you see these dots right here? Okay, so I'm going to look at those. Now let's take a look at our y values, because I need some ordered pairs. Like this one in particular, okay, this is exactly on a corner. I would use this one. This is exactly through 4 corners. I would use that one. I would not use any of the others because it doesn't go through 4 corners. So this one right here is 2 comma and then 25, 50, 75. So this would be 0.0 or 0.75. That's one. Okay, and then here's another. I'm at 3, and that's at 1. Okay. Did I show you guys yesterday how you can enter your slope formula in your calculator? Oh, I got everybody's attention now, didn't I? Okay, in order to use the calculator, you do have to write it down. y2 minus y1 over x2 minus x1. Okay, the y1s are those, or the y1, x1, and the 2's are those. So I highlighted it. Remember, I go left to right. So I'm going to put in 1 takeaway, 0.75. Make sure you put your y's in the top, in the numerator. And then my x2 is a 3, my x1 is a 2. Okay, now I'm going to show you how to put this in your calculator because it's a very particular way. I want you to put parentheses around your numerator. Okay, so I'm going to show you something. This is going to make your life really easy, and you're going to love it. Can y'all see that yet? There, now you can see it. Okay, this is my fraction on my paper, right? So I'm going to type parentheses 1 minus 0.75 and close my parentheses. Then I'm going to hit my division key. Oh, look, it gives me a denominator now. And I can just type 3 minus 2. I don't need parentheses down there. Look at this. Does it look like my paper? It sure does. Double check it before you hit enter. And then you hit enter, and oh, look at that. What does it give you? It gives you your answer, doesn't it? Do you see how I typed it in? It gave me my answer. In order to use that and not use your brain, I want to see all of this. Everybody look at the screen, please. Some of you are not looking. In order to just be able to type it in and move on about your business, I would like to see all of this. Okay? Everybody good? So we're going to have 0.25. Now what are we talking about? We're talking about dollars per what? Dollars per ounce. Look at the labels on your graph. That will tell you what you're talking about. Dollars per ounce. Okay, food supply. That's our scenario. All right, we're talking about number of days. And here we're talking about pounds. That's the abbreviation for pounds. LBS, that's the abbreviation for pounds in case you didn't know it. Pounds of food. My food supply is going by 10-pound increments. My days are going by 1. All right, so let's talk about the things we might use. This right here, that says 84, the x value is 0. This is a y value of 73. It has an x value of 1. 1 comma 73. 0 comma 84. You see how I'm pulling the numbers off of the x-axis? This is 2 comma 62. So I'm not going to do all of them, but I just want to show you where I'm getting that. Okay, what's happening to our food supply? So what's happening? People are eating, right? They're cooking, they're eating, whatever. Okay, so here we go. I need you to pick 2 points. Which one do we want? 84, 73, 62, 40, 18, or 7. Pick 2 of them. You want the 62. And you want the 18? Okay, we can do that. This one is 6 comma 18. This one is 2 comma 62. So you get to pick, doesn't matter. M equals y2 minus y1 over x2 minus x1. These are my 2's over here on the right. The y value is 18. And I'm going to subtract 62 from it. My x value is a 6, and I'm going to subtract 2 from it. I'm going to put 18 minus 62 in parentheses, and I'm going to do the little calculator thing again because Miss Bailey said it was cool to do that. So I'm going to do 18 minus 62, close it up in parentheses, and I'm going to divide by 6 minus 2. Double check, make sure I typed it correctly, and hit enter. Ooh, I get a negative 11. What does that mean? What's happening every single day? Yeah, we're losing 11 pounds of food every day. Cooking, throwing it away, eating, whatever the situation is. So this would be losing or using 11 pounds per day. That's what is happening in this situation. Okay, so negative 11, that is pounds per day. Okay, so your homework. I'm going to get a Delta Math ready. I have to double check some settings, and then I'm going to make it live. So you have Delta Math and you have a worksheet. Okay.